Welcome. Let's take a look at some things about roots. I'm going to start off with recognizing what these terms mean. The radical sign is, of course, simply the sign itself. So we'll put that above here. The radicand is the part that's inside. And the index is the root itself, or rather the number of the root. We call that the index. So when we do not see it, it means there is a 2 there. So in this case, if I put the 2, I'm allowed to, I would call that the index. If we have another one, like a third root or a fourth root or a fifth root, you have to show the number, because if you don't show it, we're going to all think that it's a 2. Now, notice this part about b. When you take the square root of the number, there's a positive and a negative, such as with 9, -3 times -3 can make a positive 9. But what we call the principal root is the positive one. So when you're solving, you use both roots because you need 2 of them. But when there were real life application type problems, then you probably wouldn't have a negative number solution and you would only use the positive. So you need to look at the context and what's appropriate. Now, the textbook for this section goes through about absolute value, and there's an explanation here that you can read yourself. And on a practical basis, we are not going to use it in this course as an issue, and just simply keep it recognizing, without having to make it absolute value. We recognize that an odd root cannot have or rather, you can't have a negative result for even powers. You can for odd roots, though. All right, that you can read yourself and just know it's not an issue. I am not going to insist on the square root, the absolute value for these. So let's take a look at it. So if we are taking the square root of 121, we would get plus or minus 11, but for the principal root, we're only going to use 11. For the fifth root of 32, that would be the number 2, because 2 to the 5th power would make that. And it couldn't be -2, because -2 5 times would result in a -32. So let's continue now here on this page with various types of, I guess you could say, principles or procedures, some different variations. Right here, x to the 10th power, what you want to do is recognize that that's actually x to the 5th squared. And that means that it's x to the 5th, because the square part here and the square index cancel each other. Now, let's use that to review about the properties for exponents. If I were to have x to the 5th times x to the 2nd, that would be x to the 5 plus 2, which we would then write as x to the 7th. But if it's x to the 5th squared, a square means writing it twice to multiply it to itself. And if we do x to the 5th times x to the 5th, now it becomes like the one above. So it'd be x to the 5 plus 5, which would be x to the 10th. Recognize also that this kind of thing, x to the 5th squared, could have also been written as x to the 2nd to the 5th power. So it'd be x to the 2nd times 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 x to the 2nd. I think I have 5 of them there. Then you would add all the 2's to make a 10. So it'd still be x to the 10th power, regardless. That's because in multiplication, you can switch things and it would still give you the same result, such as 2 times 3 equals 6 and 3 times 2 equals 6. Now, having said that, let's come to the next one here. And the difference in number 2 is that there is a number included. So you recognize that there's a 7 squared and an x to the 5th squared. And therefore, that results in 7 times x to the 5th. Yes, it is true that this could be written as 7x to the 5th squared. Let's make that a little clearer. 7x to the 5th and all of that squared. But that is more difficult to recognize than simply doing the two separate things separately, both of them with squares. However, it doesn't matter which way it's done as long as someone can get the correct answer from it. It's just a matter of which way will they be more comfortable with, especially for harder problems. Now let's look at the 5th root. Our goal here would be to make it, since that's to the 5th root, each of these things to a 5th power. For the x's, that's easy. That's like I showed before, where it can be x squared to the 5th. And for the 32, you have to think and maybe use a calculator to check numbers to find out that it is actually 2x to the 5th times x squared to the 5th, which means the original results in, put an equal sign to these, results in 2x squared. Okay. So actually, I'm going to do this with these two, show that they are the correct answers. Now for number 4, it's going to be the exact same concept. There are just simply a bunch of these. So this time it's to the 3rd power. So what I need to do is see if it's possible to make each one of those things to the 3rd power. The 64 is 4 times 4 times 4. The x to the 15th, we could put a 5 here, so the 5 times 3 makes 15. And for the y, since we have a 3, we clearly need a 10 to make it 30 to match y to the 30th, which means now we have a 4 and an x to the 5th and a y to the 10th. And there's nothing left inside the cube root because we're able to completely use each one of them up. Number 5 is actually the same concept, so it's more of a practice one. And in fact, I would say for 5 and 6 and 7 and 8, it might be a good practice thing for anyone watching to do this yourself, all 4 of them, see what they come out to, and see if you get it right. I will do them in just a moment after you have had a chance to do them yourself. Okay, welcome back. And now let me go through and do, starting with this one, number 5. So I'm now looking for a 4th root, so I need to find a number that will make 81 that's to the 4th power. The x to the 4th power, which means it's already the x by itself. And then the y something to the 4th power. Well, in this case, to make 24, this would need to be a 6. Here, we would have to take the number for 4. We'd think, what times what times what? So in this case, you could take the number 81 and do a calculator with it, or you could take another 4 with a calculator, just take a number and multiply 4 times, and we find that it's a 3. So this one becomes 3xy to the 6th. Now for number 6, it is going to be the same concept, just different numbers. And 125 turns out to be 5 to the 3rd power. Then we have x squared to the 3rd power. 2 times 3 makes 6, yes. And then it's y to the 7th to the 3rd power, which means we end up with a 5, an x, and a y to the 7th. For number 7, now we're looking for 5th roots. So we need 1024 to think what number times. Use a calculator and you find after a little bit of playing with it that it's 4 to the 5th power. So 4 times 4 is 16 times 4 is 64. and then times 4 again, and times 4 again, and you get to 1024. And then we need x something to the 5th power. So we think 35 divided by 5, and we get a 7, because 7 times 5 is 35. So our answer for this one is 4x to the 7th. Seems like a simple number after such big numbers, but that is part of what the 5th root, being so much larger, or to the 5th power, will do here. Now we have one with a 6th, and we have a whole bunch of them. The concept is still the exact same. We have the 6th root, and we think what number to the 6th power, and then it's an x to the 1st power to the 6th power. Could put a 1 there, but I don't need to. And then we need a y, something that will make it a 6 here, and z, something will make a 6 here. So going back to the y, to make a 12, we need a 2, 2 times 6. And with the z, we need a 3 for 3 times 6, for 12 and for 18. Now back to the 64, you have to take some numbers and think about them, and you can then figure out that it's 2 to the 6th power, so we'll put a 2 here. So our solution for this will be a 2 and an x, y squared, and z to the 3rd power, because all of those were to the 6th power inside the 6th root radicand. Radical sign, I should say. This was the radicand, the result of the radicand applied to the index. All right, so anyway, what is clear here is that because that's a 6th root, you need powers of 6 for the things that can be taken out and put in front. And there's actually nothing left afterwards. Another section will show what to do when you do have some things left, or when the numbers aren't exact. All right, so for now, this was hopefully helpful to see and practice using different roots besides the square root. Thank you for watching and listening.